Our next speaker is Bernd Mittnacht, and he's the owner of a 20-person engineering firm based in northern Bavaria between Frankfurt and Nuremberg. Heritage conservation and restoration projects are the main focus of his company. He's a member of the German National Committee of ECMOS, expert member of his SCARSA. So I'd like to welcome Bernd. And while he's getting set up, I want to say that we seem to be on time, but anybody that follows Bernd is going to be after midnight.
Thank you.
That was a joke. Midnight means midnight.
You have to. Stephen, it's also a laser pointer. This one?
No, it's this one here. Point it
no, the laser pointer.
The laser pointer. I think it's this one. It wasn't working before.
The pointer will not work because it's LCD.
Okay.
Oh yeah. Okay.
Okay. So. Thank you, Stephen, for your kind introduction. My presentation is, you can read, the rebuilding of the St. Martha Church after fire destruction. The content is the situation and description, then second, the original construction before the fire, then the fire, then we went to the securing measures, damage survey, then the structural restoration, after this structural design concept, and then construction and last the conclusions. So the St. Martha Church is in the historical city of Nuremberg. It's nearby the station, about 300 or 400 meters in the north of Nuremberg. It's in the King's Street, and it's nearby. You don't see the church when you are walking in the King Street. The church was built in 1385, and it consists of the nave, 17 by 17 meters, and the choir and sacristy in the northeast of the nave. In 1910, the northern and southern aisles were added. Because of its excellent acoustics, the church was used in the 16th century by the Meistersingers. So the original construction was a typical Gothic roof, a wooden barrel vault spanned over the central aisle. The side aisles had flat wooden ceilings. The outer walls are sandstone ashlar masonry. The roof was a collar beam roof with 3 floors. In the trusses, an upright post construction stabilized the roof in transverse direction. You can see the 3 collar beams. Now the fire. In 2014, the church was supposed to undergo an extensive renovation. The scaffolding for the work on the roof, the facades, and in the interior was already put up. Then, a few days before start of work, a terrible fire broke out. So the roof burned out completely, the roof collapsed, and the debris fell onto the new scaffolding in the nave. The freestanding gable walls were in danger of collapsing as they were no longer supported by the roof truss. And you see the west gable. In Germany, we have the wind west to east, and the gable was very thin. Immediately after the fire, the gable walls were secured from the outside with supporting scaffolding. The debris was then removed piece by piece with a crane. The masonry arches were supported by wooden trusses. The extinguishing water and constant rain had drenched the tops of the walls. A wooden emergency roof was erected to protect them from further soaking. The falsework supported the arches. They were equipped with hydraulic presses so that they could later be used to make the columns load-free during the repairs. Oh. Damage survey. We made a deformation true survey. After the fire, the 3D scan of the nave was repeated. We had one before. These drawings were superimposed on the drawings from before the fire. This allowed the damage caused by the fire to be accurately determined. The greatest loss of substance occurred on the columns, naturally, which were exposed to the fire on all sides. You see. The charting of the damages, all cracks and damage to the masonry and vaulting that were relevant to structural stability were charted by the engineers on site. Sandstone, in general, has the problem of surface softening, spalling, and scaling when exposed to the heat. Here are some examples of the damage pattern. Contour scaling on the surfaces, spalling up to 5 to 6 centimeters. Outer cracks widened and new cracks formed above the windows. So, structural restoration, the masonry. Cracks in the masonry were sealed and grouted. Then the walls were stabilized and connected to each other using pre-stressed anchors. The anchors, it's possible that they can make 1 centimeter exactly through the length of the masonry. In the west gable, the anchors had to be adapted to the window, and so they were placed crosswise. Sections of machinery that were no longer able to sustain the load have been replaced. The greatest damage was to the west gable, where the burning organ generated the most heat. Then structural restoration, the sandstone columns. Some parts of the columns had to be replaced. The red one. The load of the columns was distributed to the supporting framework. This was achieved by wedges and hydraulic presses under the arches. When the column was free of load, the damaged sections of stone could be removed and rebuilt. You can see when it was load free. In the same way, destroyed parts of the arches were replaced. Structural design concept. An architectural competition was organized. Many famous church architects participated. It was about 8 or 9 architects. The competition was won by Professor Florian Nagler from the Technical University of Munich. His idea was to replace the original round barrel vault with a rectangular design. There are no continuous tension members at the heat of the eaves. The ceiling and wall slabs are of timber frame construction. They are covered with diagonal layers of boards. It was very important to Professor Nagler that the board construction was not just a cladding, but had an actual structural function. The wall slabs carry the loads of the new roof and serve as bracing elements for the overall stability of the roof. Here you can see the drawing first I have done. The first design drafts for the ceiling slabs were hand sketches. This was used to develop the construction sequence, cross-sections, and details. The CAD drawings were developed from the sketches and survey plans. They were also used as the basis for the 3D structural calculations. You also can see the anchors at the west gable. The assembly drawings were realized by the contractor using a 3D model. You can see the 3D model and completed construction under. Because the walls are not parallel in the layout, the design of the board layers was particularly complicated and had to be carefully planned at the wall-ceiling connections. The 20 ceiling slabs, 4 by 6 meters large, were prefabricated and lifted into place. This is the architect. With and there are examples how it was very complicated to bring the right position to this construction. Conclusions. This example shows how important fire protection measures are, especially before and during construction work on existing buildings, see Notre Dame. It is also recommended to retrofit fire compartments in existing roof trusses in order to prevent complete losses. Nevertheless, this project is a fine example of the seamless integration of modern construction with the preservation of the character of the original building. So, thank you for your attention.